Hey everyone, sorry I can't be here for Le Chatelier's Principal Lab. I know we haven't had a lab in a while, but instead of doing the lab, I have recorded this video for you so that you can still kind of do the lab virtually. So make sure you complete it, and yeah, we'll go over it when I come back. Hey everyone, today we are doing Le Chatelier's Principal Lab. And so I'm going to be demonstrating each of the 4 reactions in this video. Before each reaction, make sure you are predicting. So knowing what you know about Le Chatelier's principle, predict which way you think equilibrium will shift, either left or right, depending on the chemicals that we're adding. So for the first one, we're going to be looking at BTB. So predict what's going to happen if you add more HCl. Okay, so take a moment to predict, maybe pause the video. Okay, next we're going to see what this looks like. So this is reaction 1. We'll start with a few drops of BTB. It's kind of a blue-green color. And to that, we're going to add a few drops of acid. So here I'm going to add some HCl, and let's see what happens to the reaction. Okay, and this is with HCl added, which is the same as adding hydrogen. Okay, next, take a moment to predict what's going to happen when we add hydroxide to this reaction. So NaOH. So here, when I add hydroxide, it's going to react with the hydrogen to form water. So let's see which way this will shift equilibrium when I add some hydroxide. Okay, we see that adding hydroxide here has turned our chemical blue. Okay, so which direction does that prove equilibrium shifts? All right, for reaction 2, we're gonna start with that BTB again. So here's that BTB. So this chemical, again, starts as this kind of greenish color. And for reaction number 2, I'm going to add ammonia. Okay, so ammonia should react with my hydrogen here. So really it's taking away hydrogen, the same effect as adding the hydroxide ions. So again, before I add this, take a moment to predict what do you think will happen when I add ammonia. Feel free to pause the video to write your answer. And here, again, I'm going to add some ammonia to this BTB. This is reaction number 2. Let's see what happens. Okay, we see a very clear change, and it becomes blue. And that's reaction number 2. Did it match your prediction? All right. For reaction number 3, we're looking at which way equilibrium shifts when I add ammonia to copper sulfate. So I'll start with a drop or 2 of copper sulfate. It's a light blue color. And I want you to predict what's going to happen if I add 1 drop of ammonia. Keep in mind this is the same as adding hydroxide. It has the same effect as adding hydroxide. So make your prediction, and let's see what happens when I add some ammonia here. Okay, so not only did it change colors, if we look closely here, we can actually see the formation of a precipitate. So remember, a precipitate is a solid formed in this reaction. So if a precipitate or a solid formed here, which way did equilibrium shift? Okay. Look at your chemical equation and make sure you explain how you can tell it shifted in that direction, left or right. Again, we do have the formation of a solid precipitate here. Okay, it says when you add lots of NH3, it starts bonding with the copper to form CuNH3. Which way would equilibrium shift if I continue to add NH3? If I continue to add that ammonia. So make your prediction for 3B here. Again, pause the video if you need to. And now I'm going to add additional drops of NH3 until we observe some kind of change. So let's see what happens here. Okay, it seems that with additional drops of NH3, my precipitate has disappeared. Okay, and which direction do you think equilibrium shifts there if I no longer have my precipitate in my beaker? Go ahead and jot down your answers. All right, for the very last reaction, reaction number 4, we're gonna add a few drops of lead nitrate to some sodium hydroxide. So again, I'll start with the sodium hydroxide, but take a moment to predict what do you think is going to happen when I add some lead nitrate, PbNO3 here. Looking at that chemical equation, is equilibrium gonna shift to the left or to the right when I add lead nitrate? So you should be looking at 4A here. All right, hopefully you made your prediction. If you haven't, go ahead and do that. I'm gonna test it out now by adding some lead nitrate. So 2 drops. Let's see if we see any notable change. Okay, so we can see that a white precipitate has formed here. Remember, a precipitate is a solid, and we can tell that a white precipitate formed because it covers that X here. So definitely some kind of white precipitate has formed. Which way do you think equilibrium has shifted then if we see this white precipitate? All right, for the very last change here, we're gonna add some nitric acid, HNO3, which is gonna react with the sodium hydroxide here. So when it reacts with the sodium hydroxide, it's actually taking away some of that sodium hydroxide. Which direction do you think equilibrium will shift if this nitric acid reacts with the sodium hydroxide? Okay, take a second to predict. Pause the video if you need to. All right, so let's go ahead and add some nitric acid and see which direction the equilibrium shifts here. All right, so I add more nitric acid, and as I do that, notice my precipitate actually disappears. Okay, I'm losing my precipitate. So which direction do you think equilibrium will shift if that happens? So make your final prediction, or your final observation rather, for the last part of the lab here. And make sure you answer those conclusion questions to wrap up this lab.